Mr. Solo, take us to warp speed.
Baba, we're not in Star Trek. We can't just go at warp speed.
Why?
Well, to answer this question, we first have to talk about the Higgs boson and the Higgs field. The Higgs boson is the quantum excitation of the Higgs field, which is a hypothetical force field that is believed to surround us, just like how water surrounds fish. Now, there's this thing called the Standard Model, and thanks to it, we can explain every single fundamental physics phenomenon other than gravity, which is explained through general relativity. It consists of fermions, which are quarks and leptons, as well as bosons. We can now understand how electromagnetism, weak forces, and strong forces work. However, it has a fatal flaw. Based on the Standard Model, the weak forces bosons should not have mass. However, we know through experiments that they do indeed have one. It was inconsistent regarding how the weak forces worked, and in the late 50s, physicists had no idea how to solve these issues. In 1964, a group of physicists, including Peter Higgs, suggested that there was a field through which particles interact with a boson to make up their mass. This new discovery was so important that it was essentially called the God particle by journalists, although strongly disliked by physicists. And in 2012, at CERN's Large Hadron Collider, it was proven to really exist. Let's take a small object, for example, and drop it into a glass of water. We then notice a splash. The splash itself would be the Higgs boson in this case. Just like the bump you see when you touch a rope. Here's a simple analogy to further explain it. Now, imagine a room full of people with two doors on each side. If an unpopular person comes in, they're gonna walk fast and make their way straight to the other door. However, if a popular person comes in, they're gonna take their time and slowly walk to the other side to reach the second door. This kinda explains how particles interact with the Higgs boson. The more mass they have, the more bosons they interact with. And the more bosons they interact with, the slower they walk or the slower they make their way. Now let's go back and answer the question asked at the beginning of the video. Why can we go at warp speed? Well, light is made out of photons, and photons are massless. Hence, they do not interact with any Higgs bosons and go straight to their way and are fast. However, the human body does indeed have mass, so it does take its time and interacts with lots of Higgs bosons, which slows it down.